Alright, we're going to take a look at motion, which is position, velocity, and acceleration. So there are going to be two videos. This is part one. I'm going to go ahead and make a tab, and I'm making the tabs a little bit longer because I believe we only have two more applications to do before we move on. Every time you get in a car, you witness differentiation firsthand. Your speed is the first derivative of your position. And when you step on the accelerator or the brake, in other words, deaccelerating, you experience the second derivative. This is a listening check. Color in the second derivative. Color in the second derivative. Now, from physics, we know two very important formulas. Velocity is displacement over time, and speed is distance over time. So velocity and speed are pretty much the same thing. The only difference is velocity has direction. It's speed with direction. So if we took a look at a graph, and let's say we're talking about displacement over time, and let's say we had a function that looks something like this. If we were to take the slope of the tangent, say at this peak right here, okay, that would in essence be the change in y, which is displacement, over the change in x, which is time, which would give me what? The slope, right? So again, what we're saying is when you take the derivative of the position function with respect to time, you're going to get the velocity. And the same thing, if you take the derivative of velocity with respect to time, you're going to get the acceleration. So remember, displacement has direction, okay, which means it could be negative, but distance is always positive. It's very important you remember that displacement has direction and could be negative, therefore velocity could be negative, but speed is always positive. Alright, so the absolute value of velocity is basically the speed. That's the only difference between speed and velocity. Speed is the positive velocity. So again, velocity is speed with direction. I can't say this enough. Velocity is speed with direction, meaning velocity could be negative, but speed could never be negative. So the way it goes, basically, if you take the derivative of the position function, you get the velocity. If you take the derivative of the velocity, you get the acceleration. Put a star on the left of position, velocity, and the word acceleration. Alright, so let me see if I can break this down so that it's in a way that you would understand. Let's say you had a car. You were in a car. I hope you can drive by now, but let's say you're in a car and you are traveling you start off at some time which is like your initial time, which is t equals 0, and you start moving. You're moving forward, right? Okay, so if you're moving forward, let's say you move forward for 6 miles. You go in a straight line for 6 miles to point B. Then let's say when you get to point B, you turn around and you go backwards for 2 miles. So I'm going to represent backwards as a negative because I'm not going in the opposite direction. That's how we represent it. So we can now say that negative is backwards, going left, and positive is forwards, going right. Color in that good looking car that you just drew. So your car goes that way, then it goes back. Alright, so the two questions I'm going to ask you is, one, what is the car's displacement? Leave a little space to answer that. And the second one, what is the total distance traveled? Leave a little space to answer that. A box around number 2. The way I like to remember this is when I'm asking myself, what is displacement? How far has it been displaced? How far has the car been displaced? Not how far has it traveled, how far has it been displaced? Whereas the total distance traveled is how many miles total. So in terms of how far it's been displaced, it went 6 miles right, then 2 miles back. So it's actually been displaced 6 plus negative 2, which is only a distance from 4 miles from where it initially started. So it's been displaced 4 miles. Whereas the total distance traveled, it went right 6 and left 2 miles, which is 8 miles, a total distance of 8 miles. If you looked at your odometer, is that what it's called? You add the two. So the thing to remember is when you're dealing with displacement, whatever two numbers you're talking about, you account for the signs and you add them. When you're dealing with distance, ignore the signs and add them. It's going to be a nice shortcut that you're going to use a little bit later. Right, so I'm going to make a little space and I'm going to write basically notes on what we do with the problems. So step 1, Take the first derivative of the position function to find the velocity. Notice I'm saying the same thing over and over again because I'm hoping that you'll understand. The derivative of position will give you the velocity. Now, a couple of things that are new. When the velocity is positive, we just learned this, when the velocity is positive in our example above with a car, it's going to be moving to the right. When the velocity is negative, that means it's going backwards, it's going to be moving to the left. And when the velocity is 0, it's going to be at rest or it's changing direction. So in our example above with the car, it changed from going right to going left, from going forwards to going backwards. So very, very important to remember that, okay? When velocity is 0, it's at rest or changing direction. Number 2, take the second derivative of position function and you're going to find acceleration. In other words, either the second derivative of position function, which is the derivative of the velocity, and you find acceleration. Underline acceleration. Now, when it comes to this, when velocity and acceleration have the same signs, when velocity and acceleration have the same signs, think about it. They are going in sync. Okay, so if they have the same signs, positive and positive, negative and negative, the car is speeding up. So they're going in the same direction, whether it's backwards or forwards, the car is speeding up. When they have different signs, think about it for a second, those signs are pulling at each other, right? One is trying to cancel the other. So what are you going to say? It's slowing down. So whether it's a positive and a negative or a negative and a positive, the car is slowing down. Now, if the velocity and the acceleration are both 0, if they're both 0, then the car has stopped. Or rather, in calculus, we say it's at rest because it's not moving. However, this one's very important. If the velocity is 0, but the acceleration is not 0, then it is changing direction. Okay, so it's momentarily stopped, but it's about to change direction. It's going to go in the other direction. So if velocity is 0 but acceleration is not 0, it's changing direction. That one's going to be so important. I'm going to say it again. If velocity is 0 but the acceleration is not 0, it's changing direction. Know it, live it, breathe it. Alright, so let me take a look at a graph. Let's say we had velocity as a function of time. Color in velocity and time. Color in velocity and time. Alright, so what can we say is happening between each interval basically? And I'm going to make like where I see like something is happening. So I'm going to make an interval and we're going to talk about what's happening at each interval from this graph. So velocity wise, if it's increasing, if velocity is positive, it's speeding. Okay, it's moving forward, it's speeding up. Okay, if it's horizontal but not at 0, it's constant velocity. If it's going down, it's slowing down. Now, interestingly enough, when velocity is negative, this does not mean it's slowing down. It's kind of like you can imagine that it's like upside down. When it's going negative, it's speeding up backwards. So it's still speeding up backwards. And now it begins to slow down, and then the velocity at this point at that dot is actually at 0, and it stays at 0. So if velocity is at 0, it's now at rest. Right, and then in this case again, it speeds up again. So velocity over there is not 0, that's why it's constant. And then over here it speeds up again. Right, so just a couple of things to note. The difference between it being constant and it being at rest is you can see where it's constant, the velocity is positive, it's not 0. Right, so if you look at where velocity is 0, where it crosses the T, right, at that point velocity is 0. Okay. That one is like an inflection point. If you remember our previous graph, at velocity is 0 there, it's changing direction. So it's changing from positive to negative changing direction. Whereas in the other two, it's going to be at rest. So again, I want to say this again and again and again. Just because velocity is 0 does not mean the particle is at rest. It could be changing direction. Check the acceleration to see, which means take the derivative of velocity and see if it is 0 as well. It's at rest. If it's not 0, then it's just changing direction. Circle this entire note. Circle this entire note or put some kind of shape around it. Again, so when velocity is positive, it's moving forward. When it's negative, it's moving backwards. Alright, so I'm just going to basically summarize everything I have just said in a table. Okay, and what I want you to do is actually try and pause and fill in the table before I fill it in. See if you can fill it in as we go, which means do you understand it? And then after that, I want you to close your book, or rather copy down the first two columns, close your book, and then try to fill it up again without looking. Okay, because again, you have to know all of this information so you can know what the question is asking and what to do. So we're going to do velocity, acceleration, the direction it's moving, the speed, the velocity. Right, so when the velocity is positive and the acceleration is positive, when it's positive, negative, negative, positive. I actually made a mistake there, should be negative, negative, but I'll correct it in a second. Just copy that down. Okay, so what direction is it moving? Remember, the direction is going to be just the sign of velocity. If it's positive, it's moving to the right. If it's negative, it's moving to the left. So the sign of the velocity determines where it's moving. So it's the positive, it's to the right. So that one's positive, that's also right. That one's negative, so it's left, and I'm just making a note so I can remember. Negative, left, positive, right. Or again, that should be negative. So that changed to negative, negative. So that's left. Positive, right. 0, I don't know because it doesn't have a positive or negative. So it's at rest. So it's not moving left or right. But I'm going to determine whether it's changing direction or whether it's completely at rest. The speed is going to be determined on the signs of the velocity and the acceleration. So if the velocity and the acceleration have the same sign, they're not fighting against each other, it's speeding up. If they have opposite signs, they're fighting against each other, then it's slowing down. So same sign, speeds up. Color in the first two columns only. Different signs, slow down. So that one's different, so it slows down. That was the same, so it speeds up. And then what happens here? Well, I'm going to come back and answer this. Let me just finish these other easier ones. So let's look at whether velocity is increasing or decreasing. What does that have to do with? It has to do with acceleration. If the sign of the acceleration is positive, it's increasing. If it's negative, it's decreasing. So if the sign of the acceleration is positive, it's increasing. If it's negative, it's decreasing. So that one's going to be positive, increasing, negative, decreasing, positive, increasing, negative, decreasing. Remember, when acceleration is 0, it's constant. Okay, so this one you gotta think about for a little bit. What does it mean for acceleration to be 0 and velocity be positive? So velocity is not at rest. So what does that mean? It means it's not going any faster. It's constant, right? So it's still moving because the velocity is positive, but it's just constant. It's not going any faster or any slower. So when acceleration is 0 and velocity is positive, it's constant. So that means the acceleration is 0. That's also constant. When they're both 0, what does that mean? It's at rest. Like it's not moving. We are staying at rest. We stop. And again, because acceleration is 0, that's also constant. When it's 0, but then acceleration is positive, that means it's about to start moving, right? To where? To the right. So then that means it's momentary at rest, and then it's going to move to the right. Put a smiley face anywhere on the left of this column. And then on this one, it's momentary at rest, but it's going to start moving to the left because we're going to start going backwards. So the sign of V and A says that that's going to be increasing, increasing, and then velocity is going to be increasing and decreasing. So again, pause the video, see if you can do that table on your own, kind of like a quick summary. But now we're just going to take a look at some examples. So we're going to check it out in part 2. You can come and join the party.